To you by Natarajan of EGS India. We are the reseller of SolidWorks in this part of India, and the agenda of this presentation is to look at the challenges in the manufacturing industry, go through a GD&T primer and usage of the same inside SolidWorks, and we will summarize it with the benefit for the manufacturing industry. Typical problems faced by the customers in the manufacturing industry are the rejections of the component at the customer place. If the rejection takes place at the design stage itself, not much money is spent. If the same is done at the tooled up stage at our own manufacturing workplace, we end up facing some costs. If the same rejection were to occur at the customer's place, then in addition to the trust deficit, we have an issue with regard to replacing the rejected components. This could involve time, effort, not to speak of the trust, which leads to incalculable damage. Second one is avoiding rework. Rework consumes a major part of our manufacturing activities before the product is shipped. Delay in product development, inconsistency in product quality. We produced a component, it got accepted. We produced an assembly, it got accepted. Over a period of time, processes start drifting and the components start getting rejected. These kinds of issues can be easily avoided if we follow a design for quality process in which the geometric dimensioning and tolerancing forms the heart of the system. What is GD&T? It's a way of communicating dimensional and tolerance requirements to both manufacturing and inspection. We are classifying the allowable imperfection in alignment with the quality objectives very clearly at the design stage. The GD&T practices are well governed by standard manuals, with the ASME being the forerunner. ASME stands for the American Society of Mechanical Engineers. The version 2009 stipulates the usage of GD&T for all features that need to be controlled except for features of sizes which could be defined using limit dimensioning or fits. Now the same thing can be applicable in terms of digital product definition data practices with the ASME Y 14.41 2003, which talks about three-dimensional models having the GD&T schemas built onto it, as shown in the left side image from SolidWorks. The standards governing the GD&T are ANSI and ANSI. ANSI is the same as the ASME, which is the Y14.5M 2009, which is the application of GD&T, and the Y14.41 2003, which is the display of the GD&T annotations in three dimensions. Additionally, you have the ISO, which has been trying to come on par with ANSI, and the application starts with 1101 and the 16792. These are some of the typical standards used by the manufacturing industries in the workplace. ISO 9000, which is undergoing a sea change and moving over to the 2015 next year, mandates the usage of GD&T towards controlled processes in organization, where the quality control is going to be process specific and not individual specific. The two schemas that typically are used in any drawings are the plus or minus tolerancing and the geometric dimensioning and tolerancing. The same part, when defined using a plus or minus tolerancing, is shown on the left side, while the part with the geometric tolerancing is shown on the right side. The one on the right side looks a little complex as compared to the one on the left because we are familiar with the one on the left. However, the tolerances that are specified on the right hand side picture are much more as compared to the one on the left and more aligned with the inspection practices that we follow on the shop floor. In addition to providing additional tolerances, if the setup and the manufacturing allowables are going to increase as you move away from your specified material condition, you get what is called as the bonus tolerance. This is where GD&T scores over the plus or minus tolerancing methods. From 1994, when the previous standard of the ASME was announced, and 2009, 15 years have passed, where the manufacturing industries have been requested to transition from plus or minus tolerancing to geometric dimensioning and tolerancing schema. Worldwide, people are moving over to the GD&T schema primarily because of the inherent benefits accrued as a result of using this schematic approach. Why use GD&T? It is important for both the designer, the manufacturer, and the inspector to understand the part dimensions in the same manner. Needless to say, GD&T is for part dimensions, while assembly GD&T is for measurable specifications for quality at the assembly level that we are trying to protect. In other words, they are called as the DFQ objectives. So GD&T at the part definition is what the standards typically talk about. The GD&T principles result in time and cost savings, as can be seen from subsequent slides down the line. It ensures adherence to quality criteria in a consistent manner. It reduces the part rejection, misinterpretation of drawings, reworking, interdepartmental crossfire, and art-to-part transformation time. One of the typical things that we have found on Indian drawings is, on the template itself we put this sentence, "If in doubt, ask." Neither manufacturer nor inspector should have any doubts with regard to the drawings that we produce. This is what the standard emphasizes. It avoids assembly mismatch, failures, and the quality problems that come as a result of it. A problem solved at the design stage costs you, let us say, 1 rupee. The same problem when you have tooled up costs you 100 rupees. And the problem when reported by the customer costs you an order of magnitude more, over and above 1,000 rupees. And not to mention of the trust. So that is where GD&T scores as compared to the conventional plus or minus tolerancing schemas. So the design criteria and GD&T, if we were to look at it, they all fall under 3 categories, namely the fit, form, and functional requirements. The fit requirement is where GD&T fits in. The form requirement comes from the conceptual design and the 3-dimensional CAD that we typically use in day-to-day life. 3-dimensional CAD has become commonplace because the 2-dimensional drawings should not have the errors. If the 2-dimensional drawings have either the view error, the interpretation error, or the tolerancing or the schematic errors, the company bleeds in terms of rework and rejections. The last one is the function, which is typically validated using finite element analysis, computational fluid dynamics, kinematics, so many different ways in which this can be solved. In essence, design criteria and GD&T come in on the fit, form, and functional requirements. We put something called as the design failure modes and effects analysis. This comes in as a result of the statement of requirement. The design failure modes and effects analysis protects the quality objectives and is built into the process when the GD&T drawing is released. So, how does GD&T work? We have been doing plus or minus tolerancing for quite some time now. So, it's a good idea for us to go back and revisit the methodologies that we need to implement with regard to ensuring that a drawing is correct and complete in all aspects. I repeat, correct and complete in all aspects. The first thing is to identify the part surfaces that would serve as origins and provide specific rules to establish the starting point and the direction for measurements. GD&T emphasizes how the part should be set up in manufacturing and in inspection so that as the designer intended in the assembly process, it is replicated at the manufacturing, assembly, and the inspection stages. So the first step, needless to say, is with definition of datums. Next one is to convey the nominal or the ideal dimensions or the basic dimensions and the part orientation, features orientation from the origins to other surfaces. Third one is establish the boundaries and or the tolerance zones for specific attributes of each surface along with specific rules for conformance. This is nothing but providing the tolerances on the drawing. So the first step that we need to do is to identify the part surfaces that would serve as datums. Next, put on all the ideal dimensions that we would have loved to produce the component at. Third, specify the tolerances at the part feature levels to either position, locate, or orient the features with respect to the datums. The last one is allowing the dynamic interaction between tolerances in features on a part, between tolerances in features across parts, while simulating the different assembly possibilities to maximize the tolerance. Typically, the last step is incomplete. It is not done by the design department either because of the lack of awareness or because we don't have the top software tools and technologies to do it. GD&T is incomplete without the addressing of the quality paradigms at the design stage using these 4 simple steps. I repeat, datum first, nominal dimensions next, put the tolerances and visualize and see the dynamic interaction of tolerances towards the qualitative objectives that you are looking after the components have been assembled. 95% of the problems that we face in the industry are relating to assembly issues. So the cost indicators or the expenses provided for as provisions by organizations is predominantly quality oriented, either towards eliminating the assembly defects or towards investing in better processes and technologies with regard to the process capability to identify and achieve the critical tolerances. Now, typical problem that is solved using GD&T can be seen in this picture. If you take a part with a hole, there are more than one way to locate the measurement of the hole location. The inspection method 1 or 2 can be adopted, which would be well in place with regard to the plus or minus scheme in order for us to accept the component in invert quality acceptance. However, what is the method that is being used in the assembly? That's what needs to be communicated unambiguously to both manufacturing and inspection. This is where the setup ambiguity goes away because GD&T provides proper critical information necessary for manufacturing and inspection. Specifically, we say in Tamil, Mudalum Konal, Mutrum Konal. So the datum is the primary thing that we need to address if we were to take care of most of these issues that come from downstream manufacturing, especially in assembly or in the functional requirements down the line. Now, typically when we take any part, let us say an internal feature of size or a hole, and we look at the tolerance zone in a plus or minus, you see on the left hand side you see a square tolerance zone or a rectangular tolerance zone depending on the tolerances provided in the X and the Y directions or the horizontal and the vertical directions. Now if you look at the right hand side, you are seeing a circular tolerance zone being specified using a GD&T schema in deference to a plus or minus tolerancing schema. Why is this important? If we are putting a receiver gauge, it is checking a circular tolerance zone. It is not checking the corners of the plus or minus tolerance zone. Number 1. Number 2, it is telling the setup in which the components have to be put in place to assess at the part level so that you would not have problems at the assembly level. Number 3, the mating features are cylindrical surfaces. Why are we putting a plus or minus tolerance when the features that we are trying to protect are cylindrical? This is exactly where GD&T provides for mechanisms by which the way the components are taken into assembly are the way in which they are delivered at the design stage with the manufacturing drawings. Now as you can see over there, GD&T provides you with 50%, 57% more area as compared to the plus or minus tolerancing schema. So one of the typical fear that people have when they look at a GD&T drawing is, how expensive is it to produce this? It is actually cheaper because you would be allowing more components to get accepted in comparison to what you would see otherwise with the plus or minus tolerance, where you would have deleted it or where you would have rejected the components. So the argument that GD&T leads to a higher cost per piece is unsubstantiated because you are giving more tolerance, as you can see in the next picture when we are going to talk about the bonus tolerances. The ubiquitous feature control frame is shown on the top, where it reads from left to right. The position of the hole axis or the feature of size shall lie within a diametral tolerance zone of 700 microns when produced at its maximum material condition for the size, when the object is restrained on A as primary and being placed on A as primary, locating it on B and C as secondary and tertiary respectively. So MMC stands for maximum material condition, typically the largest shaft or the smallest hole. The LMC condition is typically the smallest shaft or the largest hole. Now in assembly, the primary criteria is MMC because it is typically the largest shaft and the smallest hole. When getting together having a problem, you have fitment problems and assembly problems. So if we are able to protect the MMC boundary, then needless to say, as you move away from the MMC, which is the largest shaft to a smallest shaft, your problems go away because your problem was not there in the first place at MMC. This is exactly why if you put M on the drawing, it is for assembly. If you put L on the drawing, that is because you want enough material when you are removing it on a casting so that you don't machine in the air, or you want to protect a minimum wall thickness, or you don't want to have a near breakout condition of a hole going towards the flange, or you are using exotic or expensive materials like brass, copper, titanium and things like that, where you want to protect the amount of material that are going into the object. In those cases, you would be using the least material condition or the LMC. Now the bonus tolerance comes in. The bonus tolerance comes in when you move away from MMC towards LMC. This is where this methodology scores over plus or minus tolerancing in accepting more components that would have otherwise passed, that you would have rejected at the plus or minus tolerancing level simply because you did not allow the tolerance to grow as you moved away from MMC. When you move away from MMC, you are enabling manufacturing and inspection to accept more components that would have been assembled off-center more as compared to the normal tolerancing, primarily because assembly is your criteria. Now, as you can see on the left side, you can see the virtual condition boundary or the boundary of the pin with its size and location that are getting accommodated in what is called as the virtual condition boundary, that the shaft, that the hole does not transgress or cross over. As long as this boundary is maintained with sanctity between the two mating parts, the GD&T assures that the components would be acceptable all the time as long as they are produced to spec with GD&T. Now, normally with the plus or minus tolerancing, you can see on the left side the square tolerance zone sitting there with a circle around it being the MMC virtual condition boundary schematic. Now, if you look at it further on, you will see that as you move away from MMC to LMC, the tolerance grows. In other words, at MMC it is 57%, beyond MMC it is much larger, even up to 100% tolerancing. So the myth that GD&T is more expensive as compared to plus or minus tolerancing is clearly negated with this approach in GD&T. Only GD&T emphasizes the relationship between the diameter tolerance and the center positional tolerance as compared to the plus or minus approach. So the blue area denotes the bonus tolerance that is provided on the drawing using the feature control frame when it is associated with the feature of size. GD&T is for designers who design high precision components, who design products to be produced in high volume, who perform tolerance stack-up analysis manually subsequently down the line, who must correctly and dimension and tolerance the designs so that downstream manufacturing issues can be avoided, anyone who suffers from assembly fit problems and other quality issues. These are the people that need GD&T on a daily basis for ensuring consistent quality. One of the things that we have found is GD&T is for mass production, it is not for unitary production. There is no differentiation in a drawing for mass production as compared to unitary production. Quality, whether it is a unitary production or a mass production, the paradigm called quality remains the same: acceptability at the customer level in terms of fit, form and function at an affordable cost. So, why should we care about GD&T? Because it saves time, and you need to automate the process of GD&T so that irrespective of which engineer joins the organization, they will be able to produce the drawing using a similar process so that the variances in the drawings can be eliminated to provide relief from grief for downstream manufacturing people. Lean manufacturing requires GD&T as well. Excuse me. Datums, these are imaginary, geometrically perfect references. That's what we give on the drawings. Datums, if inappropriately chosen, leads to grief down in the manufacturing place. So datums are the first primary elements that we need to fix based on design for assembly. The 14 characteristic symbols, starting with form, which is level 1 control, orientation, which is level 2, level 1 is size, level 2 is form, I apologize, level 2 is form, level 3 is orientation, and level 4 is rotation. Runout is a combination of circularity and concentricity for circular runout, cylindricity and concentricity for total runout. Profile can be used with or without datums so that they control either form, or it could control higher levels of control in addition to form and size, orientation and location. So all these symbols are covered in the SolidWorks interface so that designers can leverage on this and provide drawings with correct and complete tolerancing. What you're seeing is the form tolerances, what is allowable, what is not allowable, what are the different ways in which you can inspect it with regard to the tolerance zones, and how you would apply on a feature or a feature of size, in this case a feature. Then you would have the orientation tolerances provided for specifically as a level 3 tolerance, wherein parallelism, perpendicularity, and the superset of these two may be namely angularity for any angle is specified. The GD&T schema is shown over there. As can be seen over there, this leaves a very unambiguous interpretation. Now we need to understand, when we are putting the GD&T controls on the drawing, every additional control is going to cost the company money. So the number of GD&T controls that need to be established on a drawing depends on the design for quality objectives that we are trying to protect, with as little control as possible so that maximization of manufacturing and reduction of the overall product cost is achievable. Similarly, the level 4 is the location tolerances, where you specify and you complete the GD&T schema with multiple datums so that the components can be located. This is the highest level of tolerance. So if the first level of tolerance, which is contains nothing but the limits dimensioning or the fit dimensioning of the sizes are given, and the highest level, which is the location, that is given, then orientation and form, which happen to be level 3 and level 2, are subsidiary to them or are built inside them. So the highest level is the location, which could either be position tolerance, concentricity or symmetry. Runout, as you can see, is a measurement specification that we try to comply with at the design stage using the runout schema. It is necessary to have datums so that we can inspect it according to the inspection procedures provided for. Similarly, for profile, you have it with and without datums. If it is without datums, it is form control. If it is with datums, depending on the restraints available with datums, it could be orientation control and or location control in addition to size and form. Now, GD&T, as we can be seen, reduces or decreases the manufacturing costs, reduces or eliminates the physical prototypes, eliminates confusion between design, manufacturing and inspection, specifically in terms of fixturing and measurement schemas, and it yields bigger bonus tolerances than the plus or minus tolerance. And it's a new functionality which has been incorporated right from 2008 until today, which is 2015. In fact, there has been a sea change in the application of this over the last 7 years, that today you can automate the process of GD&T inside SolidWorks using what is called as the Dim Xpert. The Dim Xpert helps the users to consistently produce drawings irrespective of which user produces it, according to the 14.41 digital product definition enunciated by ASME. The TOL analyst is a simple tolerance stack-up analysis that is available inside the SolidWorks Premium module. In addition to that, you have the add-in module called as the Segment, which takes care of three-dimensional tolerance stack-up analysis, wherein you can go to the level of specifying or the process capability, incorporating the process capability, the CP/CPK of the process that is going to be used, or you could use it to predict the PPM and the critical to quality indicators. Now what is DimXpert? DimXpert is an intelligent automated dimensioning and tolerancing of three-dimensional models that have been developed using SolidWorks. It gives a visual impact. If the part is all green, then it is completely toleranced. Otherwise, it will show you the conflicts in the tolerance zones and help you to resolve the same. It automatically displays the same thing, which is in three-dimensional annotation, as you can see on the right-hand side in a two-dimensional drawing, and it is integrated with the tolerance stack-up analysis, be it tall analyst or segment. So it applies the GD&T, it applies and displays the tolerance scheme per the industry standards. Just like when you are writing an email, you are doing a spell check and a grammar check for your email, or you are reporting that you do in your documentation. Similarly, the spelling and the grammar check is what DimXpert does on your drawing to eliminate the quality issues that would have otherwise occurred downstream in the manufacturing shop floor. It is easy to change something upfront on the design side by applying intelligent manufacturing concepts at the design stage than working towards overcoming the grief that happens downstream in the manufacturing subsequently. One of the things that we have seen is the Indian manufacturing industry struggling to look at GD&T, especially on parts that need to be supplied from outside of India. The fixturing, the gauge development are all so easy to use with GD&T that people make a lot of mistakes, leading to up to 40% rejection. This is something that our customers have eliminated as a result of implementing GD&T with SolidWorks inside of it. So under construction, ISO is still an evolving standard. So you can see both the standards are still under construction because consensus among member nations is a prerequisite for the standard to come out. Now, the benefits of the DimXpert are, it's most of the time that is spent in the drawing creation is in dimensioning and tolerancing, which is a huge problem that needs to be solved, and DimXpert addresses that perfectly. Without it, manual dimensioning and tolerancing scheme, no way to know if the drawing is complete or correct for manufacturing. With DimXpert, it is automated and can be ensured for correct manufacturing. One of the things that we have found is it is very difficult to get good resources consistently in organizations to produce drawings without mistakes. It is an HR issue that most of our customers are facing, primarily because of lack of knowledge at the educational stream, which translate into manufacturing requirements downstream in the manufacturing shop floor that the industry demands. This is one way to alleviate the problem, is to automate this inside using the DimXpert, so that the drawing, whether it is produced by XYZ, it's going to remain the same and it's going to be standardized, and the downstream manufacturing problems that come as a result of incorrect, improper or absential specifications are ruled out, and it costs company no more money. It automates the part of the drawing detailing per the industry standard specifications. There is no need to be an expert to apply the correct dimensioning and tolerancing schema. If you apply for flatness a datum, it will come back and say no datum is allowable for flatness. So to that extent, the syntax is brought in. That's why we refer to it as the syntax and the grammar. Ensure that the design fit and function and reduction in cost even when outsourcing of design happens. Manufacturing would not have to guess at the tolerances and the datums because it is unambiguously put on the drawing. So who needs DimXpert? Companies which outsource product designs, anyone who makes detail engineering drawings, inexperienced in GD&T, experienced in GD&T, but you want to automate the process so that people downstream can look at it and replicate it while you can solve customer related queries and high-end customer issues by going through your tolerance stack-up analysis using popular softwares called such as Segment, which work inside SolidWorks. And company which do not want to waste paper, they want to go in a drawingless approach, they also use the DimXpert. So the day is not far off in India as compared to the West, which has always been a forerunner, to eliminate the 2D drawings and to work with the three-dimensional drawings with the GD&T schema annotation put right on top of it, so that the manufacturers and the inspectors have a visual screen as to how the components are laid out and where the tolerances are, and how the same thing can be achieved using the process capability that exists in the organization. So it is for designers who want to create detailed part drawings, annotate the parts in 3D and get customer approvals or internal approvals, want to know designs are completely dimensioned or not, use geometric tolerancing in addition to the plus or minus tolerancing. There are companies which still practice plus or minus tolerancing and they want to migrate to GD&T. When they are going through this process, the old drawings are still in plus or minus tolerancing. As the product evolves, they want to switch over to the GD&T. They use the plus or minus and the GD&T schema together. The design high precision components and currently having assembly fit problems. Now, typically the parts, some of the parts that are machined, some of the parts that are cast and machined, surfaces which need to be controlled in industrial design, machined components, forgings, where drilling, milling, turning are all parts of the manufacturing activity. GD&T with DimXpert beautifully fits into the scheme of things there. So the user interface, the ubiquitous SolidWorks interface, only thing is in addition to that you have the DimXpert feature manager where all the datums and the feature control frames find their place in. If the model changes, this gets updated automatically. So it is referential with regard to the 3D model that you have been creating. So the parametric model, when it changes, all these associativity also get updated as a result of that. Typically, all the manufacturing related features such as drilling, machining, notch creation, chamfer, counterbore counter spacing, slot production, so many different areas in which the feature types are automatically recognized. If you bring in models from other CAD, three-dimensional CAD platforms such as Pro Engineer, Siemens, Unigraphics, Solid Edge, Inventor or other things, you can use the feature recognition capability which exists inside SolidWorks Professional and also apply the GD&T schema automatically on those models, even though the models are not relatively created inside SolidWorks. That is the power of SolidWorks in terms of interoperability with other CAD packages. So in other words, as a vendor, as a supplier, a customer or customers are not driven towards buying so many different CAD platforms for interoperability with their existing customers. They could take any format they want and then apply the tooling and other requirements that are there on the product definition at their end, and then they can send over the manufacturing shop floor drawings and things like that. So the interoperability becomes a prerequisite at this point in time. To save costs and effects, one software can be used for multiple purposes in addition to producing the 2D drawings either in annotative three-dimensional manner or 2D just like AutoCAD. So the manufacturing feature recognition, as I have told you earlier, is an intrinsic part of the DimXpert main features. So these can be done for both imported bodies as I told you earlier or for the solid modeling features. So the information which is there in the 3D digital product definition comes off home. The feature recognition process goes through very simple steps in identifying, either recognizing the processes automatically or manually. So these are the different ways in which DimXpert enables manufacturing companies to ensure that the product near net shape definition is given without any ambiguity so that errors, rework and rejections downstream can be eliminated. The functionality schemes, as I repeat, can be done using both GD&T as well as the plus or minus schemas as shown over here. The same drawing produced using geometric dimensioning and tolerancing on the left side and the plus or minus tolerancing schema on the right side. The auto dimensioning scheme takes your model, asks you to give either the choice of plus or minus or geometric dimensioning and tolerancing, asks you to do it for the entire model or for specific features, and it automatically lays out the GD&T schema as shown over there on the right side, and you can see whether they are colored green so that the complete tolerancing of the entire setup has been done or not. This saves manufacturing a lot of money, and the if in doubt ask on the drawing need not be there. So what you are seeing is the datums, the location dimensions, the size dimensions, the geometric tolerances given on the drawing with pattern recognition for multiple holes, whether it is imported bodies or for the SolidWorks created model itself. Then you can apply the composite feature control frame, your location tolerances, orientation, so on and so forth. Now as you can see over here in the next slide, you will be able to see color coding fully constrained in terms of tolerancing is what green is all about. Yellow is under constrained, red is over constrained, gray color or any other native color, it is not recognized by DimXpert, which means you need to define it better. Otherwise manufacturing is going to have an issue subsequently down the line. So this is exactly what it is before and after as shown in the tolerance status. It's a unique capability of SolidWorks which has been in existence since 2008 and as being refined. The manufacturing industries worldwide employ this technology extensively. One of the popularity of SolidWorks is primarily because of this particular functional requirement that manufacturing needs and deserves. If the West can use this and do it, why can't we do this in India, especially in a global competitive environment? That is where the thrust of EGS is towards ensuring that the GD&T and the schemas of this kind are implemented in organizations for the least cost. It is integrated with the drawings, and the annotation views can be imported into the drawings. Here can be shown over there, reducing the amount of effort and time that is required to create a drawing. So needless to say, even an untrained resource with 2 to 3 days understanding of the DimXpert with the GD&T and the annotation schemas can be ready to make production ready drawing error free. Now, the tolerances that are typically used in companies, the process capabilities are intrinsic attributes for the companies. It could be a medium precision, high precision, critically precision, or normal precision industry or a manufacturing requirement. Those can be put in the functionality can be put inside the document properties as it is shown over here. When you go over to the next slide, as you can see, the general tolerancing as well as which are the block tolerancing can be specified over there with the tolerance class as per ISO 2768. Now these are the defaults that DimXpert would take unless you override it subsequently down the line. Next comes the size dimension. You can specify symmetric, unsymmetric, unilateral, different kind of tolerancing schemas, the basic settings that are required for that, so that the same thing can be adhered to by the DimXpert when it is creating the auto dimensional schema. Then you have the location tolerancing, both plus or minus as well as angularity coming in there. And here you are able to locate the part either in terms of plus or minus or in terms of GD&T as we have done earlier. Chain line dimensioning, baseline dimensioning are also provided as shown there. The classic advantage of DimXpert is not only building in the knowledge base that is required for correct and complete specification of the tolerances, but also to ensure that user upon user produces it in the same standardized manner. Now, one of the things that typically a drawing comprises of, as you can see in the arrows provided on the right side over there, are the material modifiers that come in the datums. Lot of times people ignore this primarily because of a lack of knowledge. A material modifier such as an MMC specified on the DRF, which is nothing but the datum reference frame, refers to a feature of size being called upon at MMC for the tolerance of position that is provided there. The advantage of this is when you apply the MMC to the datum feature of size, by default in a drawing, it reduces the manufacturing costs and accepts more parts that would have otherwise been rejected. Your receiver gauges, typically you needs to use this especially for datum features of sizes when they are protecting the MMC worst condition boundary, virtual condition, worst case mating boundary. This is exactly what DimXpert provides you with by giving it as a default option. Then you can give your composite feature control frame, and you can specify your chain line dimensioning and your baseline dimensioning as given over here, the methods. And then for the chamfers, the different schemas as given by the ASME and the ISO. And then you have the combined dimensioning as well as the separate dimensioning specifically for slots, as can be seen in the next slide. For the slots, you can see the way it is dimensioned using combined dimensioning or using separate dimensioning with the 2R. Now, one of the advantages is you can eliminate the redundant dimensions as shown on the left pane over there, which helps you to avoid confusion downstream in manufacturing. This is a very important thing that is required in all aspects of manufacturing to prevent that ambiguity. So elimination of duplications is avoided with this approach, and it's a check in place. Now, things to remember. Using DimXpert inside SolidWorks, correct and complete application of the tolerances without having to be an expert is achievable. That does not mean interpreting the drawing does not require an expert. It definitely requires an expert. But at least we are able to produce drawings without the manufacturing errors that typically come with less experienced engineers. Second one is the decreased manufacturing costs because less prototypes and looser tolerances are acceptable, and because we know exactly how those tolerances come in terms of the fit and the function, and eliminating the manufacturing and inspection guesswork. So this gives you an overview of all the different methodologies that can be employed with both geometric dimensioning and tolerancing and using SolidWorks without having to recreate the drawings or go back and correct the errors in the drawing subsequently down the line by doing what is called as the first time right approach. One of the biggest things about GD&T is it is there to stay. Whether we like it or not, manufacturing industries have to move to GD&T to stay competitive. Not only in terms of understanding the customer's dimensional drawings, but also in terms of their own products that people are coming up with, be it in fixturing, be it in tooling, be it in special purpose machine design, wherever it is. If consistent quality has to be brought in, then GD&T becomes the mainstay for manufacturing organizations. If you have any further questions, you can contact us on info@egs.co.in as given in this slide, or visit our website and leave a note. We have been working with SolidWorks with the developers since 1999, and we are committed to providing not only the software per se, but the process of implementing GD&T in the organization. Based on our consultancy services, which we have been doing since 1993, we have a training division where we provide GD&T tolerance tax, DFMEA, and the finite element analysis training. We thank you all. If you don't have any further questions, we thank you all once again for having taken your valuable time off in attending this program. We look forward to hearing from you. Have a great day and a wonderful new year ahead. Thank you.